Hello and welcome to another session where I'm going to share with you the results of my experiments using the normal JDK and using GraalVM. And this is going to be very interesting if you are really interested to increase or to decrease the latency of your Java program, because GraalVM is a fantastic utility from Oracle, and using GraalVM, as you can see here, you can reduce the runtime of your Java program at least 5x times. So if you are not using GraalVM yet, I would suggest that you can walk through this video, you can see this video and start experimenting with GraalVM. Well, I'm Shomik. I'm a Java and backend senior developer and architect who loves sharing his experiments learning through YouTube video. And I would like to welcome you once again to this video to stay along with me and to see the results of this experiment of using GraalVM and seeing the output. So what is GraalVM and why do we need it at all and how to download it? So in this section, I'm going to answer all these questions. What is GraalVM and what are the main advantages of using GraalVM and what are the main use cases for which we should try to use GraalVM, and from where do we get it and how we can download. GraalVM is also basically a Java development kit, and it is written in Java, but it has some very special capabilities apart from our very standard JDK. So GraalVM actually helps us to generate the native images, and in fact, it has got many advanced use cases, like you can also create your own language using GraalVM. In order to know more about GraalVM, just type GraalVM in your Google search bar, and then you can go to this website, which is graalvm.org, and here Oracle has documented everything related to GraalVM. It's a fantastic documentation, and also I think it's one of the most powerful things in the Java ecosystem, because using this native image of GraalVM or using the native image, you can actually create Java program which runs as fast as, or if not as fast as, it can give a very close run for its money to programs written in C or Rust or Golang language. So if you want to stay within Java ecosystem and still want to run programs which are very fast, then GraalVM is your option. So in order to download, you can click the download button and then you will be taken to this page. There are various options that you can actually choose to download. For example, you can download container image. You can download it using SDK man if you're using MacBook. You can download using scripts, and you can also download the binaries using this drop down. So in this drop down, you can choose which version of Java you want and what is your operating system. So these are the various ways you can actually download GraalVM. And in order to just get started, you can go to this Get Started section and run this very simple program, this simple Hello World program, and time this program in the Java world. Time this program using Java and time this program using the native image. And even for this very simple one-liner Hello World program, you will see that the native version runs, I think, at least 5x faster than the Java version. Actually, the native version runs as fast as C or Rust, something like that. Okay, and also in the subsequent section, I will give you demo of two different functions, two different programs, wherein I will show you how you can actually use GraalVM to generate native image and run it much faster. So let us start with experiment 1. In this first experiment, we are going to see how we can actually have a for loop calculating square root 100,000 times or 1 lakh times, and the same program, the same Java program will be run using the Java command, which means using the normal JVM Java. And then we are going to use the native image. We are going to compile the program to the native image using the GraalVM SDK. And then we are going to see how that native image, which is a binary file, how soon that runs. The result would be interesting. So let us go ahead and see that. Okay, so I have cloned my code base from my GitHub repo, and the link to my GitHub repo, the link for the specific branch will be mentioned in the description. So please find out the branch and clone that branch. It contains just 2 sample programs. So Now I'm going to show you this sample program for loop demo. And as you can see, the program is super simple, like it executes a for loop 100,000 times or 1 lakh times, and it just calculates the square root of a number within that for loop. And then I'm adding it to a list. And I'm calculating the execution time. So what I'm going to do is I'm going to first run the program using the Java command, which means the standard way in which we run. And then I'm going to create the native image, which means I'm going to translate the program into a binary format. And then I'm going to run that and see how fast that one runs. So let me quickly set Java. And then I'm going to do a quick compile using the GraalVM JDK. So I'm going to do a quick compile. It has compiled the program, and now if I run it, so the time taken in milliseconds is approximately 52 milliseconds. So that's an approximate number. It's an approximate number. Well, now let us try to create the native image. And in order to create the native image, I'll have to run the program, run the binary native-image. So just like the bin folder of the JDK contains Java C, Java, also the bin folder of a GraalVM JDK contains another or a few more additional binaries, and one among them is known as native image. So since I have actually set the bin folder in the path of the GraalVM JDK, therefore, if I type native image, it should be able to find out the native image executable from within the bin folder of the GraalVM JDK. So now if I do native-image and then if I give this class name, then it will actually generate the native image. It will scan through. So this is a process which takes a while. So the native image is generated, and you can see it that the name of the native image is for loop demo. And now I'm going to run the native image just using // and for loop demo. See, the time taken is 11 milliseconds. I'm again going to run the Java version. Again, the time taken for the Java version is 47 milliseconds. So it can vary a little bit here and there, but as you can see, it's roughly 1/4 or 1/5. The time taken in running the native image is roughly 1/4 or 1/5. So it might vary, and it will vary slightly, but we have a 4x improvement if we are using the native image. Now we are going to conduct another experiment in which we are going to do something similar to the previous experiment. Like we are going to again run a for loop 100,000 or 1 lakh times, and within the for loop we are going to calculate a hash using the very standard MD5 message digest 5 algorithm, and we are going to see how the program performs when we run it using the Java command versus when we actually generate the native image using GraalVM SDK and then run the native image. So let us go ahead and see the outcome. So let us now see the second experiment. It's also again very similar to the first one. So here is another class which is named hashing demo, and what the class is going to do is it's going to execute a for loop. It's going to execute a for loop, and what I've done here is this for loop, the number of times the for loop will execute will vary, and I can actually pass that as a command line argument. So I can actually run the for loop 10 times, 100 times, 1,000 times, 1 million times, whatnot, depending on what argument I pass to the program from the command line. So again, within the for loop, it's going to generate a message digest, which is basically a hash of a slightly varying string within the for loop. So basically, I'm going to run the program again using the Java command and using the native binary. And in order to save some time, I had already pre-compiled the program and also pre-generated the native image, as you can see here, in order to save some time during the demo. So that's why I have pre-generated. Now, sorry. Now let us run the program using the familiar Java command, which is the Java way of running. And then what we are going to do is Java hashing demo, and maybe we want to run it some 1,000 times. And let's see. So it takes 58 milliseconds to run 1,000 times. And now let us try to run the native version, which is this one, and also 1,000 times, and it takes 1 milliseconds. Unbelievable. Again, it takes 1 millisecond. So actually, if you run the program lesser number of times, it can actually give you even more performance benefit if you're using GraalVM, if you're using native image. Because if you run it more times, then if you are running it using Java, then gradually the just-in-time compilation optimization will kick in, and therefore even the Java version will become performant, and in some cases it can become even more performant. So with this said, I would like to end this video, and I would like to make a request. If you have liked this video, if you have liked my presentation, and if you think I have added value, go ahead and subscribe to my channel, and please share your feedback and share it with all others who you think would benefit from this. Thank you and have a nice time.